Hello and welcome. Today we're going to be looking at the unit test on vectors. This is one of the topics in Precalculus. Now, vectors is one of the most difficult topics in Precalculus, which is why we're going to be going through all of these questions to make sure that you understand how to approach and solve these questions. If you like these videos, please be sure to like and subscribe. And with that, we're going to start on our questions. But first, even if you don't understand these questions, even if they seem a bit hard, we are going to have a special topics video just focused on vectors because this is a hard topic. If you want to, please be sure to check that out. But let's get started on these questions now. Okay. Tenley hit a golf ball. The ball fell 80 meters from Tenley in a direction that is 70 degrees south from the westward direction. Here are a few vectors where the magnitude of A equals the magnitude of D equals 70 meters, and magnitude of B equals magnitude of C equals 80 meters. Which vectors can represent the ball's displacement? Well, let's see. So Tenley, I have a notebook here that I'm writing down on that I'm going to show you. This is how I'm going to do my work. Right, so Tenley is hitting a golf ball. It goes 70 degrees south from the westward direction. Right, so what does 70 degrees south from the westward direction mean? Well, if we're going 70 degrees south from west, we can write the westward direction is going to the left, right? And south, 70 degrees south of that, is going to be going like this. Let me show you. Something like this. Okay, this red arrow. See this the blue one is west. This arrow right here is going to be the 70 degrees south from west. You see it's almost going to completely south, but this is 70 degrees south from west. And that's the direction it's going in. And that's 70-degree angle. We know that. The 70-degree angle. And we know that the angle itself, 70 degrees south from west, is going to be going to the bottom left. So that means that it can only be C. That's the only possibility. And we can move on to the next question. All right. So second question is the vector u equals 5, 8. Find the direction angle of u. Well, what we're going to do is we're just going to sketch this out. Okay, so we're going to draw our vector here. And we're going to draw both of the components of said vector, which is going to be magnitude 8 in the y direction and magnitude 5 in the x direction. Magnitude of 5 in the x direction. Okay, so this is what our vector is going to look like. All right, so that is vector u right there. This is length 5, that's the x component. This is 8, the y component. And we're going to find the direction angle, which is going to be the angle right in here. Right, that's what that angle is going to be. This from the vector to the eastward direction, the x-axis. That is going to be our direction angle. So that is our direction angle. And how do we calculate that? Well, theta is just going to be equal. That direction angle theta is just going to be equal to the inverse tangent of the opposite over adjacent, because that's what tangent means. So opposite over adjacent is 8 over 5. So I'm going to pull out my calculator, and I do inverse tangent of 8 over 5. In degrees, make sure. And I get 57.99 degrees. Right, 57.99 degrees for the nearest 100th. And that's our direction angle. And we can keep going. Right, the vector u is shown below. Find the component form of u. Okay, so that's what we're going to do. How do we do that? Well, we're going to, of course, draw the vector, sketch it out again. Test the vector out. We know that has a magnitude of 12 and it has a 20-degree angle. Okay, 20-degree angle. So then we know if something has a 20-degree angle and a magnitude of 12, then the x component is going to be 12 times the cosine of 20. 12 cosine 20. Because cosine is going to be adjacent over hypotenuse. Adjacent is the x. So adjacent over hypotenuse is going to be the x over 12, and I'm multiplying by 12, so I get x. The y is going to be 12 sine 20. Remember, sine is opposite over hypotenuse, so we're going the y over 12, and I'm multiplying by 12 to get just y. And now if we write this in component form, the 12 cosine 20 for x becomes 11.28. 11.28. And the y coordinate, 12 sine 20, becomes 4.10. 4.10. So our answer is going to be 11.28, 4.10. Neither of them are negative, they're both in the positive direction, and that is our answer. Let's keep going. Alright, find the magnitude of u. Let's see how we're going to do that. Well, we can see that we're going, this vector u, I'm going to write it in component form. So u is equal to what? Well, it's going from x coordinate of 4 to x coordinate of 8, so it's going up by 4 in the x coordinate, and it's going from y coordinate 2 to y coordinate 8, so that's plus 6 in the y coordinate. Now the magnitude of u is just going to be the Pythagorean theorem on the two components. Okay, so if I do the magnitude of u, which is a vector 4 comma 6, that's going to be the square root of 4 squared plus 6 squared, which is going to be the square root of 52, which is going to equal 2 times the square root of 13. Right? Or if you want to be exact, or well, actually that is exact, but if you want like a decimal or something, that would be like 7.21. But I'm going to write it as 2 squared root of 13 because that's like the actual thing, the accurate thing, and we can keep moving on to the next question. Okay. Question, what is this, 5? Here's a drawing of vectors d, e, and f. Okay, we have our drawing of vectors d, e, and f. What are we going to do? Which equation correctly describes d in terms of e and f? Okay, let's see. So, so I noticed that d is going up and to the left, to the right. Right, so it looks like that, and it's connecting the start points of e and f. Right, so what do I think about that? Well, what I'm thinking is that if I take f and I flip f, right? If I flip f, then what am I going to get? Let me draw that out. If I flip f, right, the vector f, so I multiply by like -1, then I end up with the same vector, but the arrow's pointing the opposite direction, right? So I end up with that. Let me draw that out. Alright. So I got my vectors here. 3 vectors. Alright. So I got my vectors here. And I got these vectors. What do I know? Well, I notice that since this is negative f, right, so I multiplied by -1, I flipped it. That on this drawing right here at the bottom, I can see that if I add up e and negative f, that's me going from this starting point right here up to here, and then back down to here, right? So D is the resultant from my adding E and negative F. So what does that mean? It means that D equals vector E, plus negative F, also known as E minus F. Right, now if you're wondering how we did that, well, if you add two vectors, right, you put the start of one on the end of the other. Okay, so that's how you match it up. So we had the start of negative F on the end of vector E. And then you add them together by taking the start of the first vector that's not paired with anything to the end of the second vector that's also not paired with anything. That's how you add vectors. Now here we have D equals vector E minus vector F. D equals E minus F. And we can move on to the next question. Alright. Araya is walking on a boat that is sailing in the ocean. At a certain point, the boat encounters a current. Araya walks at a speed of 5 kilometers an hour in the westward direction relative to the boat. The boat is sailing at a speed of 35 kilometers an hour in the northward direction. The current pulls the boat at a speed of 12 kilometers in the eastward direction and a speed of 7 kilometers per hour in the northward direction. Okay. What is Araya's absolute speed after the boat meets the current? Alright, so we have a lot to unpack here, right? So we're just going to draw a diagram because that is what you do with vectors, with a lot of things, right, in math. You can simply get there by just visualizing it, by writing it down, by drawing out what is going on. It makes all these words, all these different vectors, a lot simpler. So let's do that. Okay, so we have Araya walking, so that's going to be 5 kilometers per hour, 5 in the westward direction. And then we have the boat in the northward direction, when sailing in the northward direction. I know my diagram's not to scale, as you're about to see, but it passes. It's good enough. And then you have 12 kilometers an hour in the eastward direction for one of the currents, and the other part of the current is 7 kilometers per hour in the northward direction. 7. So this is what my diagram looks like. Okay, so I have the 5. This is her walking westward. This is the 12 eastward current. This is a 35 for the boat, the 7 for the current. So I'm going to add that stuff up, and I end up with 7 in the eastward direction for the horizontal, and I get 42 in the northward direction. Alright, now I'm trying to find the absolute speed, or the magnitude of this vector, this new resultant vector. That's going to be 42 squared plus 7 squared. Take the square root of that, which is going to be, put on our calculator, it's going to be the square root of 1813. Square root of 1813. Which can also be written as 7 times the square root of 37. But they're asking it to the nearest tenth, so we can just evaluate the square root of 1813, which is going to be 42.6. 42.6. And we can keep going. Here are vectors v and w. Alright, so we have these two vectors, and we're asked to find the magnitude and direction angle of v plus w. Right, so it shouldn't be too hard. Right, how are we going to go across doing this now? Alright, let's think. Let's think about what we're going to do when you have these like direction angles, and you have different direction angles, you have different magnitude of vectors. I'm not asking you to add them up. But so what did we do last time? We just put them end to end, and then we drew it, which works. I mean, like that is how you add vectors. But see, the problem here is that that time we just drew it. Like we have no idea of figuring that out. We have no way to figure that out without doing something with the vectors themselves, with the vector v and vector w themselves. But there is something that we do with the vectors, and it's called splitting it up into its components, right? We did that throughout this unit test, right? I remember for one of the questions we just took like a vector and we found the components, and then we've been taking the components, finding the magnitude, right? So what we're going to do here is we're going to take these vectors v and w, and what we do is we split them up into their components. Now, why does that help us? Well, it gives us an x and a y for each of them. Then we add the x's together and we add the y's together. And now we get a new vector with two components. And then we take those components and use them to find the magnitude and direction angle. And it seems complicated and it is actually kind of long, but it's not that difficult of a concept to grasp once you do it a couple times, right? It's not really that much different from saying in the coordinate plane you have, say, a 0.54 that you're adding to a 0.27, right? You're just adding the x and adding the y, and that's your new coordinate. That's what we're doing here, right? We have a point here that we don't know what it is, but we know that it's 8 away from the origin. That's all we know, and the direction angle. But we don't know what the coordinates are for that. So we're going to find the coordinates, and then we're going to add the x's and y's and turn that back into another vector. Let's do that. Let's go see how we do that. All right, so let's start with v. All right, so v, well then red. So it's a magnitude 8 vector, and it has let's see. So it has a magnitude, or it has a direction angle of 100 degrees. Now 90 of those degrees is going to be at the y-axis, so we're going to get 10 degrees, roughly. 10 degrees for 10 degrees for this angle inside. 10 degrees. Now, something you might notice here is that the degree is actually like in between the vector and the y-axis, which is going to mess things up. And well, it's not really going to mess things up. It just means we have to do it a different way. When we had the angle between the vector and the x-axis, we had that cosine was x and sine was y. When you have it between the y-axis and the vector, then cosine becomes y and sine becomes x, and we'll see why that is in a second. Okay. So here's the diagram of vector v. Vector v. Okay. So vector v is right here. Okay? Vector v is right here. This is the magnitude 8. This is 10 degrees. And you see that if we take the cosine, that's going to be the adjacent, or the blue, over the 8. I'm going to multiply by 8, obviously, to get just the blue, the y. And the green at the top, like, where is that? Right here. That is going to be sine of 10, right? Opposite over hypotenuse times the 8, obviously. So we're going to do that in the same way that we've already done this, right? It's just that we're using sine for the x and cosine for the y. Sine is x, cosine is y. So that means that this y is going to be 8 cosine of 10. The x is going to be 8 sine of 10. 8 sine of 10. All right. So we have 8 cosine of 10, 8 sine of 10. And so we can write vector v. As 8 sine 10, which is going to be negative since it's going in the left direction. 8 sine of 10. So negative 1.39. And then you have 8 cosine of 10, which is positive, it's going up, which is 7.88. 7.88. And so 7.88 is there. And we can do the other vector, right? So W going bottom left, and we're going to draw out our components again. Right, this time we're doing it with respect to the x-axis. The angle is going to be with respect to the x-axis. So we already have 180 degrees. Our direct angle is 210. So our angle in there is going to be 30 degrees. 30 degrees. And of course, as usual, when you're doing it with respect to the x-axis, it's going to be um, y is going to be sine. So it's going to be 3 sine 30, and x is going to be the cosine, so 3 cosine 30. And of course, you don't need to memorize that for x axis it's going to be sine for y and cosine for x. You don't have to memorize it, right? Like when you get into a problem like this, you can find out pretty easily what is what just by thinking about SOHCAHTOA, right? It's, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent, of course, is opposite over adjacent. Okay, so anyway, we're going to write this out. It's vector w. Right now, both of the components are going to be negative, so it's going to be negative 2.60, and it's going to be negative 3 sine 30, which is going to be negative 1.5. All right, now we add that up, so we get that v plus w. V plus w is going to be the negative 1.39 plus the 2.60, which is going to be which is going to be negative 3.99, and then the y is going to be 7.8 minus 1.5. So 7.8 minus 1.5 is going to be 6.38. 6.38, that is it. Positive 6.38, it should be mentioned. Alright, so we can sketch out this vector. Alright, it's going to look something like this. So this is v plus w. V plus w. Hang on. That's v plus w. Now, we can use the Pythagorean theorem to find the magnitude. So magnitude of v plus w, we're just going to use the Pythagorean theorem to find, which is going to be 7.5. Magnitude is going to be 7.5. As for the direction angle, well, we're going to find the angle inside here first. Right, theta, right here. Let me show it to you. This theta, and then we're going to do 180 minus that theta to get the direction angle. So there you have, it's going to be inverse tangent. Theta equals inverse tangent of the y, which is 6.38, over the x, which is going to be 3.99. We can drop the negative since we're just talking about side lengths here. So take the inverse tan of the 6.38 over the 3.99. And you get 57.99 degrees. Now we're going to do 180 minus that. So it's going to be the direction angle. It's going to be 122.0 degrees. 122.0 degrees, right? So our magnitude is 7.5. Our direction angle is 122.0. And we can move on to the next question. Adrian and Bridget each went for a walk. The displacements at the end of the walk are represented by vectors A and B respectively. Which option best describes the meaning of the following statement? The vector A equals vector B. Adrian and Bridget finished their walks at the same distance from their starting point, but not necessarily in the same direction. Adrian and Bridget finished their walks at the same distance and in the same direction from their starting points. Adrian and Bridget walked the exact same path. Okay. What do we think? Well, it's not the same path. That's not what displacement means. They did walk the same distance from their starting point, but does that be in the same direction? Well, their displacements by the end of the walk are represented by vectors A and B. Vectors have magnitude and direction. So if the vectors are the same, then that has to be the same direction. We can keep going. All right. A boat is traveling at a speed of 30 kilometers an hour in a direction that is 45 degrees rotation from east. At a certain point, it encounters a current at a speed of 10 kilometers per hour in a direction that is a 270-degree rotation from east. What is the direction of the boat's velocity after it meets the current? Find your answer to the nearest integer. Okay. Well, let's see. Okay, let's see what we have here. So it's traveling at a speed of 35 kilometers in a direction that is a 45-degree rotation from east. So we're at east, and we go 45 degrees. So 45 degrees at 30 kilometers per hour. At a certain point, occurs a current at a speed in 10 kilometers per hour, 270-degree rotation from east, going straight down. And it's 10 miles, 10 kilometers an hour. Alright, so what do we do? Well, we're going to split up, as always, as we kept doing like this entire unit test. We're going to split this 30 into vectors. But this is how vector addition works. Even one of them is completely flat. It just makes it a bit easier because you don't have to split the second one into vectors. So it's 45 degrees, right? So they're both going to be cosine of 45, sine of 45, which is both the same thing. So 30 times cosine of 45 or sine of 45 is going to be 21.21. So I have 21.21 and 21.21. Now we also have 10 going down, so the full vector is going to be 21.1, 21.21 to the right and 11.21 up. Okay, so that's going to look something like this. Going to look something like this. This red arrow right there. This one. That red arrow is what that vector looks like. Alright, so we can draw on the components again. But we don't really need to find the components this time because we already have the components. What we need to do is find the angle. So if we're trying to find the angle of this, we have to find the angle in between here. That is theta. Theta, of course, is going to be the inverse tangent of the y, 21.121, over the x, 11.21, and that is going to be what? That is going to be 62 degrees. 62 degrees, and that is our answer. Okay, so that was the unit test on vectors. We've just done all of these 9 problems. If you're still confused, be sure to check out our special topics video on vectors. I know it's a very difficult topic, which is why there are more problems for it. There's more practice for that. Until next time, I'll see you when our next precalculus video goes out. See you then.